A 50,000 cubic meter per day plant that has been designed to produce water ranging from sub-zero to 32 degrees Celsius seawater temperatures using cutting-edge technology. One of the first seawater reverse osmosis projects in the world where brine is fully reused. A project for its uniqueness that has been granted a demonstration project status by the NDRC of China. This is the Qiaofeidian Seawater Reverse Osmosis Desalination Plant, China's first large-scale potable water seawater reverse osmosis desalination plant constructed in only 18 months. To produce 50,000 cubic meters a day of product water, some 125,000 cubic meters a day of seawater is extracted from a channel connected to the Bohai Bay via submerged piping to an intake chamber. Within the intake chamber, seawater is first passed through 50mm coarse bar screens to remove solids and rubbish, before passing through a further 3mm traveling band screen to remove fine solids. Following the initial screening, seawater is then pumped via vertical pumps some 1.5 kilometers to the main processing plant. The intake system has been designed to offer 100% redundancy in operation. The Qiaofeidian Seawater RO plant has been designed to run and operate 24/7 automatically. Operators from the control room can monitor the plant and with a simple click of a button or mouse can adjust what is happening in the plant. Once the seawater reaches the main processing plant, this is where the real work begins. The first pre-treatment step is to run seawater through the dissolved air flotation units, also known as DAF. The DAF consists of a series of above-ground circular tanks into which seawater is fed. An air dissolving unit produces micro air bubbles, which are introduced and mixed into the seawater and assisted by coagulation to aid in the reduction of suspended solids by forming a sludge. A rotating arm constantly circulates the tank, separating the sludge from the clarified seawater. The clarified seawater is then directed to an underground tank before being fed via a series of centrifugal pumps to the ultrafiltration system. Prior to entering the ultrafiltration system, the clarified seawater is passed through a series of self-cleaning filters, which provides a further screening to remove particles greater than 150 microns. The last step of the pre-treatment system is the ultrafiltration or UF system. The UF has been designed to consist of 20+4 train configurations, leaving 20 in operation with 4 as spares for various times of the year. The UF technology used for Qiaofeidian is an inside-out, low-pressure membrane that has pores of around 20 nanometers, which is small enough to prevent germs and viruses from passing through. Membrane technology for UF was selected for its advantage in reducing footprint as well as ease of operation. In order to keep the UF operating at its optimum, it requires regular backwashing. A fully automated backwashing system has been integrated into the design of the overall UF system. Following the UF, the ultrafiltered seawater is sent to the ultrafiltration filtrate tank, where it is ready for the next stage of the process. The seawater reverse osmosis system is the heart of the plant and is where the salt is separated and water is produced. From the UF filtrate tank, The ultra-filtered seawater passes through one more 5-micron safety guard filter known as the cartridge filter. The cartridge filter aids in preventing any loose fibers or other contaminants that may have come from the UF system or storage tank from blocking the RO membranes. The seawater reverse osmosis system consists of 5 independent trains that can each produce 10,000 cubic meters a day of product water. Each train is configured as a single-pass system in order to meet the required product water quality. There are a total of 132 pressure vessels per train, with 7 membrane elements per vessel, totaling 924 membrane elements in each train. In order to separate the salt from the water, the reverse osmosis process requires a pressure of above 55 bar. A high-pressure pump is used to feed the ultra-filtered seawater and provide the necessary pressure to the seawater reverse osmosis membranes to create the osmotic effect. As traditional reverse osmosis treatment is energy hungry, Aqualink's very own proprietary energy recovery device, the Recuperator, has been incorporated into each of the 5 seawater reverse osmosis trains in order to reduce the energy consumption. The Recuperator is a work exchanger that uses the pressure and flow of the saline reject brine from the reverse osmosis membranes to pressurize pre-treated seawater, which in turn lowers the energy required to produce fresh water. Similar to the ultrafiltration system, in order to keep the seawater reverse osmosis membranes performing optimally, systematic flushing and cleaning is required to clean any film that might have built up on the surface of the membrane during operation. Permeate water directly from the reverse osmosis process is typically low in mineral content, alkalinity, and pH, and can be corrosive to downstream pipework. To overcome this, the permeate is passed through a post-treatment system, which is a remineralization process that increases alkalinity and hardness. The remineralization system used for Chowfeidian consists of dosing the permeate with carbon dioxide and then passing it through a calcium carbonate contactor. Following this, the product water is ready to be pumped for usage. Another part of the process is the chemical dosing room. The chemical dosing room consists of the necessary storage and distribution pumps of the various chemicals that are used throughout various processes within the plant. The air compressor room contains the units which produce and distribute the relevant air at pressure for equipment, instruments, and pumps throughout the plant. The Chowfeidian seawater reverse osmosis plant also has its very own state-of-the-art laboratory in which any water throughout the process steps can be analyzed. This can help in determining the performance of the various process steps and aid in the operation of the plant. The Chowfeidian Seawater Reverse Osmosis Project is a true achievement from its quick delivery to the cutting-edge technology and smart engineering implemented. A design for which this facility will be remembered for years to come.